Okay, everyone. Today we're going to talk about how to integrate trig functions, specifically sine, cosine, and secant squared. So these formulas are on your reference sheet if you need them. If they ask you to integrate cosine of x, it will be sine x plus c. Integrating sine of x gives you negative cosine x plus c, and integrating secant squared x will give you tan x plus c. Now, if it's in the form cosine of ax plus b, you divide by the coefficient of the term, change it to sine, and add a c. For sine of ax plus b, we get 1 over a, negative 1 over a, because sine turns into negative cosine. Negative 1 over a cosine of ax plus b plus c. And finally, secant squared ax plus b integrates to 1 over a tan of ax plus b plus c. So here are all your formulas. These formulas on the left are on your reference sheet. So just remember that when you're integrating, take the coefficient of the term x and divide by that number in front. Let's check out some examples. Integrate sine of 2x. So you see sine becomes negative cosine. We divide by the coefficient of x, so negative 1/2 cosine of 2x plus c. Cosine integrates to positive sine, so we don't worry about a negative. Do 1 over 3, because we divide by the coefficient, change it to sine of 3x, and add a c at the end. For secant squared x over 2 dx, first we're going to take the constant and move it in front. Okay. So we get 4 times. Now I divide by 1/2, and dividing by 1/2 is the same thing as multiplying by 2. Change the secant squared to tan, so 2 tan of x over 2 plus c. You can just distribute the 4, and your final answer will be 8 tan x over 2 plus c. So those were indefinite integrals. It's not between any two given x values, so that's why we're adding the c, so don't forget that. But let's look at an example of a definite integral. So we're integrating between 0 and pi over 4 radians for 3 minus 2 sine 2x. So the 3, when I integrate, becomes 3x. Sine integrates to negative cosine. But since this is already a negative, I will have negative 2 over 2, since we're dividing by this, times negative cosine 2x. So it really becomes positive 2 over 2, which is 1, cosine of 2x. Now, since it's a definite integral, we're not adding c, but we're integrating between 0 and pi over 4. So 3 times pi over 4 plus cosine of 2 times pi over 4, which is equal to pi over 2. Then we subtract 3 times 0 plus cosine of 0. Here, if I distribute, I get 3 pi over 4. Cosine of pi over 2, or 90 degrees, is 0. 3 times 0 is 0. And cosine of 0 is 1. So I end up with 3 pi over 4 minus 1 as my final answer, which represents the area of this curve between 0 and pi over 4. So let's look at further integration of trig functions, which is going to involve using our trig identities to make it easier. Okay, so let's talk about how we can integrate sine squared x and cosine squared x. So we're going to use our double angle cosine identity in order to make our lives easier. So the cosine of 2x equals 1 minus 2 sine squared x. So we want to solve for sine squared x and get it by itself. I have 2 sine squared x. By adding this to this side, and then 1 minus cosine 2x by subtracting cosine 2x on this side. Now I need to divide by 2 or multiply by 1/2. So sine squared x equals 1/2 times 1 minus cosine 2x. So if you're asked to integrate sine squared x, you're going to integrate this expression instead. Now let's do the same thing with cosine squared x. Cosine 2x is also equal to 2 cosine squared x minus 1. Therefore, 2 cosine squared x equals cosine 2x plus 1, and cosine squared x equals 1/2 times cosine 2x plus 1. So let's look at some examples where we can use these trig identities to help us integrate. So if we're asked to integrate sine squared of x, you'll replace that with 1/2 times 1 minus cosine 2x. Pull the constant out. And integrate what's inside your parentheses. 1 integrates to x. Cosine turns into sine, and we divide by the coefficient of x. And then we add a c. So we can go one step further and distribute the 1/2. 1/2 x minus 1 over 4 sine 2x plus c. What about 3 cosine squared 2x? So if cosine squared x is equal to 1/2 times 1 plus cosine 2x, then if I want to integrate cosine squared 2x, I can replace it with 1/2 times 1 plus cosine 4x, since I'm doubling the value of the coefficient of x. So pull your constant in front, and we're going to integrate 1/2 times 1 plus cosine 4x. Now 1/2 is also a constant, so I can have a 3 over 2 in the front and just integrate 1 plus the cosine of 4x. Three over 2 times x plus 1 over 4 sine 4x plus c. Distribute your 3 over 2. We get 3 over 2x plus 3 over 8 sine 4x plus c. Another third example on this part would be find the integral of sine to the fourth x dx. Well, sine to the fourth we don't know, but we can do sine squared x squared. Sine squared x equals 1/2 times 1 minus cosine 2x, and we can square this whole thing. So that becomes 1 over 4 times 1 minus 2 cosine 2x plus cosine squared 2x. Okay, and we know from the last example that cosine squared 2x equals 1/2 times 1 plus cosine 4x. So let's distribute everything. First, I'll distribute that 1/2 that's inside. Then I'll distribute 1/4 to each term. Okay, combining like terms, 1/4 and 1/8 becomes 3 over 8x minus 1/2 cosine 2x plus 1 over 8 cosine 4x. So this is equivalent to our original equation, which was sine to the fourth x. This equals sine to the fourth x. So that means this is what I now need to integrate. Excuse me, this should have just been 3 over 8, not 3 over 8x. I guess I was integrating before they told me to. Okay, so yes, 3 over 8 integrates to 3 over 8x. Cosine becomes sine, and we divide by 2 in the front. So we have negative 1 over 4 sine of 2x. Then 1/8 divided by 4 becomes 1 over 32 sine of 4x, and here is where I add my c. If we're asked to integrate tan squared x. So we have the trig identity, 1 plus tan squared x equals secant squared x. So tan squared x can be rewritten as secant squared x minus 1, and we know how to integrate secant squared x, so this will make it possible to do these problems. So let's say you're asked to find the integral between 0 and pi over 4 for 5 tan squared x dx. The first thing I'm going to do is pull the constant out. Then I will replace tan squared x with secant squared x minus 1. Secant squared x integrates to tan x, and negative 1 integrates to negative x, and that's all between 0 and pi over 4. The tangent, so we do 5 times tangent of pi over 4 minus pi over 4. Then we subtract tangent of 0 minus 0. tangent of 0 is 0, and 0 is 0, so that's gone. Tan of pi over 4 is 1, and then we just distribute the 5. So the area under the curve between 0 and pi over 4 is 5 minus 5 pi over 4. So you're told in the next example, if y equals secant x, prove the derivative is tan x times secant x. So y prime, or y, excuse me, equals 1 over cosine x. So we have to use the quotient rule, where u equals 1 and v is the cosine of x. Now here we're differentiating, so you have to use those rules, not the integration rules. So be careful and read the problem. The derivative of 1 is 0, and the derivative of cosine x is negative sine of x. Remember that order matters with the quotient rule. So you always start with v times u prime minus u times v prime all over v squared. 0 times cosine x cancels, and you have negative 1 times negative sine x, which becomes positive sine x in the numerator. In the denominator, cosine squared equals cosine x times cosine x. So here my sine x over cosine x becomes tan x, and my 1 over cosine x becomes secant x. So that's what they were asking us to prove. Part 2 says integrate between 0 and pi over 4 cosine 2x plus 5 tan x secant x. Okay. Cosine turns into sine because now we're integrating. Divide by the coefficient, change it to sine, leave it as 2x. So here is where part A helps us. If the derivative is tan x over secant x, then that integrates to secant x. So they gave us the integral for tan x secant x by having us work from the original equation to the derivative. Now we're going backwards. So this is the integral, and we have to plug in 0 and pi over 4. Sine of 2 times pi over 4 is sine of pi over 2. Okay, sine of pi over 2 equals 1. So this is just 1/2. 5 divided by 1 over the square root of 2 is 5 radical 2. You could just be plugging this into your calculator. Just make sure it's in radian modes, because all calculus with trigonometry is in radians. Okay. Sine of 0 is 0, and cosine of 0 is 1. So here we have 0 plus 5, which becomes 1/2 plus 5 root 2 minus 5. So if you have 1/2 minus 5, you get 5 root 2 minus 9 over 2 as your area under the curve. Okay, a couple more examples. So these are ones where we're going to integrate proofs with our integration. So it will start by saying prove that 2 cosecant 2x times tan x is equal to secant squared x. So cosecant 2x is equal to 2 over the sine of 2x. Multiply that by tan x, which is sine x over cosine x. Now sine 2x is the double angle identity. So it's equal to 2 sine x cosine x. The 2's simplify, the sine simplify, we get 1 over cosine squared x, which equals secant squared x. Then it will ask you to integrate. Here it's between pi over 3 and negative pi over 3. We're going to integrate 5 plus cosecant 2x tan x. Now be careful with these problems. Secant squared x equals 2 times cosine 2x tan x. This is only 1 times cosecant 2x tan x. So in order to get this by itself, I'll divide both sides by 2. Therefore, I'll replace cosecant 2x tan x with 1/2 secant squared x. We're still adding that to 5, and it's still between negative pi over 3 and positive pi over 3. This will be easier to integrate. So it integrates to 5x plus 1/2 tan x. When I plug this in, we get 5 pi over 3 plus root 3 over 2 minus negative 5 pi over 3 minus root 3 over 2. So I'm subtracting negatives in both cases, so it's going to be addition. 5 pi over 3 plus 5 pi over 3 equals 10 pi over 3. And root 3 over 2 plus root 3 over 2 is simply root 3. And our final example involves angle addition. So first we'll prove, well, given that cosine is 3x minus x, or cosine of 3x plus x, so this is cosine of 2x and cosine of 4x, show that the cosine of 2x minus the cosine of 4x equals 2 sine 3x times sine x. So for cosine, we do the cosine of the first angle times the cosine of the second angle, switch the sign in the middle, and repeat with the sine of both. And we're going to do cosine of 2x minus cosine of 4x. So here, cosine of both angles again. And then since it's a positive in the middle, we're going to switch that sign and do sine 3x sine x. So cosine 3x cosine x minus cosine 3x cosine x, those cancel. Now I have sine 3x sine x minus negative sine 3x sine x, which becomes positive 2 sine 3x sine x, which is what we were trying to prove. So therefore, we want to integrate between 0 and pi over 4 sine 3x sine x and show that this equals 1 over 4. So just like the last example, look, we know that cosine 2x minus cosine 4x equals 2 times sine 3x sine x. But here we just have sine 3x sine x, so we have to multiply this by 1/2. We can pull that constant in front. Let's integrate. Divide by 2, change to sign. Divide by 4, change to sign. And we'll distribute the 1/2, so we get 1/4 sine 2x minus 1/8 sine 4x, and we need to integrate between 0 and pi/4. Okay, if I plug 0 into sine, it's going to equal 0. So we don't even have to plug in the second number. Let's just deal with pi/4. 2 times pi/4 gives you pi/2. 4 times pi/4 gives you pi. The sine of pi equals 0, so we can cancel that. The sine of pi/2 equals 1. So we've proven that the area under the curve is 1/4.